Okay, I obviously am not in school today, so I'm going to tape my lecture on how to handle calculations with Sig Figs. It's a pretty tough concept, so really pay attention, even though I'm not there. First thing I wanted to do is fire up this PowerPoint quickly. You copied this down the other day, but here's what it says. In addition and subtraction, comma. Whereas down here it says in multiplication and division, comma. Um, there's different rules for different mathematical operations. So in addition and subtraction, the answer may contain as many decimal places as the least number of decimal places. And in multiplication and division, the answer may contain as many significant figures as the measurement with the least number of significant figures. The similarity is the word least. The difference is addition and subtraction. The only thing that matters is what's going on to the right-hand side of the decimal place. For multiplication and division, what matters is significant figures. And so that's really the tough part because you always have to remember what rule to use. Now, before I go any further, I don't know how that happened. Sorry. Let's make this bigger. Make sure I'm still recording. I didn't do something weird. Yeah, still recording. Um, so let's review. Um, let's just take a number. Oops, I know what my issue is. I need to grab a pen. Sorry about that. So I'm going to take this number 0.0204 and let's make it a measured number. So I put a gram here. And I want you to understand the difference. This number has 1, 2, 3, 4 decimal places. Um, decimal places, you've probably been doing that since late grade school. And then, however, let's grab a different color. You learned on Monday that significant figures are different because they have rules. Rule 1, if it's not a 0, it's significant. Rule 2 doesn't apply because we don't have a final 0, we have a final 4. Rule 3, this is sandwiched, and so this has 3 sig figs, but 4 decimal places. So the first thing you got to understand is that a decimal place and a significant figure are very different. Let's do 100.500. Um, this has 1, 2, 3 places after the decimal, but it actually has 6 sig figs. Rule 1, if it's not a 0, or if it's not a 0, underline it. Rule 2, we have a final 0 after the decimal. That makes this 0 sandwiched and these 2 zeros sandwiched. And so this has 6 sig figs. All right, new slide. Okay, so then the next thing we need to talk about is units. And so I just want to equate this to ninth grade algebra. Sorry, units. So in your math class, if I asked you to add 3x plus 4y, you would tell me the answer is 3x plus 4y because you can't add numbers if they don't have like terms. Um, However, if I asked you to add 3x plus 4x, you would tell me, since these are like terms, um, I could add these and get 7x. And units work just like variables. Units are a lot like variables. Okay, for instance, if I ask you to add 3 inches and 2 feet, you can't add them. You can't say that that's 5-inch feet. But if I say, okay, well, you can only add numbers or subtract numbers if the units are the same, well, the fact that 1 foot is the same thing as 12 inches, if you change 2 feet to 24 inches, Now it's a lot like this problem up here. If the variables are the same, you can add them. If the variables are not the same, you can't add them. In this case, you could add them. This is 27 inches. So the first thing I want to review with you is this. If you add you can't add numbers if the variables aren't the same. You can't add numbers in chemistry if the units aren't the same. Now, crazy thing though, you can multiply them. If I asked you to multiply 3x times 4y, weird thing is you can do that. That's 12xy. Or if I ask you to multiply 3x times 4x, you can still do it. This is 12x squared. So what you got to know about variables is even if they're different, you can multiply and divide them. 3x over 4y is 3/4 x over y. I mean, you can do that. So keep in mind, you can multiply or divide numbers if the units aren't the same. Weird things happen in science. Sometimes you have a velocity in meters per second and you multiply it by time, which is seconds. And we know that things on the top and the bottom cancel. And so a meters over second times a second is a meter, just like x squared over y times y over 1 in your math class that would cancel. So weird thing, multiplication and division, you can multiply if the units aren't the same. Addition and subtraction, they have to be the same. Okay, so now what I'm going to tell you is it's very easy. Honestly, I think you'll find this very easy if you follow these simple rules. One, whenever you're doing a calculation in chemistry, do the math like a middle school student. In other words, middle school students always use calculators. It drives me insane. Use a calculator. Okay, that's the math answer. Two, make a decision. Are you adding and subtracting? Because if you are, you count the least number of decimal places. Or are you multiplying and dividing, and then you count the least number of Sig Figs? All right, now, next thing I want to show you is that that gold sheet you got yesterday. It's right here. I am going to work all of these problems in 4. So I just want you to know where I'm getting these problems. I'm going to go really fast. So this is 4A. I'm going to try to use lots of colors. 4A is 0.243 seconds plus 76.720 seconds plus 4.694 seconds. Now remember, when you're adding, the units have to be the same. Since they're all seconds, we can do it. The unit stays the same. It's seconds. I'm going to go to this online calculator. Maybe. I don't know what happened to my online calculator. That's crazy. There you go. Here it is. So what I'm going to put in here is 0.243 plus 76.720 plus 4.4694 equals, and I see 81.4324, so I'm going to go back here. I get 81.4324 seconds. 4324. Okay, I'm going to go up here and grab the eraser because that's a little bit too far away. No, I don't want that. Sorry, guys. And so seconds. Now here's the crazy part. I'm going to switch colors. We are adding. When you add, you don't count sig figs. You're only interested in what's going on to the right of the decimal point. This number has 3 places to the right of the decimal point. This has 3 places to the right of the decimal point. This, however, I dropped this. There was a little, this is supposed to be 4.4694 seconds. This actually has 4 decimal places. 3, 3, 4. It's always the smallest, which is 3. So we can only keep 3 places to the right of the decimal. By the way, the stuff to the left of the decimal just comes along for the ride. And so the answer in chemistry is 81.432. This is 0, 1s, 2s, 3s, and 4s. Truncates, meaning you just chop it off, 5, 6, 7, 8s, or 9s. Get rounded up. And that is your first problem. Let's go back. Let me just show you. Oops. Do the math like a middle school student. Just put all the numbers in the calculator. Decide if you're adding and subtracting, and then round to the least number of decimal places. If you're multiplying and dividing, you have to round to the least number of sig figs. All right, so next page, let's do this. Here is 4B. You can look on your sheet. It's 427 meters per second times 0.65 seconds. I do this on a calculator. So I'm going to hit this, and I am going to hit clear. We're done with that problem. Very easy, just very easy problem. 427 times 0.65 equals 277.55. So you just, first thing I want you to write down is 277.55. Don't worry, get the answer like a 7th graders. You got a meter, a M on the top, a S on the bottom, an S on the top. These are going to cancel. The units don't have to be the same, and so this will be a meter. And now this is the crazy part. You are multiplying. You don't count decimal places. Luckily, because this number has 0, this number has 3 sig figs. This number has 2 sig figs. What's smaller? 2. You only get to keep 2 sig figs. I get to keep this 2. So I get to keep 2 sig figs. This 7 we get to keep, but we have to round it up to an 8, because if the number touching the box is a 5, 6, 7, 8, or 9, you round up. And don't tell me that the number closest to 277.55 with 2 sig figs is 28, because if I'll give I want to do banking with you if that's true. $277.55 does not round to $28. If this is a 3-digit number, this has to be a 3-digit number. So you need to fill in this last place with an insignificant 0. And basically what I'm telling you is the number closest to 277.55 meters that only has 2 sig figs is 280. Okay. Next one, 4C. Which is 3.35 meters times, oh no, that's 4D. Hold on, grab an eraser. Mrs. High is going crazy. 4C, I was doing 4D. 4C is 1,048.0 kilograms over 7.23 cubic meters. This is a unit of density. You don't know that yet. Okay, step 1, do the problem like a 7th grader. So we're going to hit clear. We're going to do 1048.0 divided by 7.23 equals, oops, I got divided in there twice. That's not good. I'm going to hit equals. We get this big, giant, ugly number. Okay, I'm going back here to be obnoxious. Let's say, okay, I don't want that. 144.0 9515966. Nothing cancels. You got a kg on the top and an m cubed on the bottom. Okay, now you're dividing this number up here. Come on. Why are you being that way? This number up here has 5 sig figs. Rule 1, rule 2, this is a final zero after the decimal point. This is sandwiched. This number down here has 3 sig figs. 5, 3, 3 is smallest. We get 3. I want you to box in 3. The number touching the box is a 9. The best answer to this problem in chemistry, the only answer to this problem in chemistry, is that this should be expressed as 145 kilograms per cubic meter. Okay, D is chomping at the bit. 3.35 meters times 2 meters. I go get the calculator and I hit clear. This is our last answer. And 3.35, 3, I have a 3 there. 3, oops, that's bad. No, what do I want to do? I want to go backwards. 3.35 times 2 is 6.7. Yep. Let's go back here. 6.7. A meter times a meter is a square meter. Are we doing multiplication where we count sig figs, or are we doing multiplication and division? You count sig figs. Addition and subtraction, you count decimal places. This number has 3 sig figs. 1, 2, 3. This number has 1 sig fig. 1 is smaller than 3. That means you only get 1 sig fig, and so the best answer to this problem is 7 square meters, because the number touching the box is a 7. 5, 6, 7s, 8s, or 9s make this round up. The closest number to 6.7 with only 1 sig fig is 7 square meters. Now, why do we write it like this? This is a crap measured number. It was only good to 1 sig fig. If you use a crappy number in a calculation, it makes your answer crap. So you can't have an answer that's more accurate than the least accurate measurement that you used in your calculation. All right, so here's E. I like this one, 321.21 grams per cubic centimeter plus 0.256 grams per cubic centimeter. Now, I'm assuming that you guys can, I'm not going to go to the calculator for a while. When I do this on the calculator, I will get 325.466. This and this are the same units. You can only add and subtract if they have the same unit, and the unit doesn't change. Just like 5x plus 2x is 7x, the x doesn't change. Okay, but because we're adding and subtracting, we're now counting sig figs. We only care about the numbers on the right-hand side of the decimal point. This has 2 decimal places. This has 3 decimal places. We don't put it in brackets. Brackets are sig figs. It's always the smallest. We only get to keep 2 places after the decimal. So this after the decimal is going to be 0.47, but the stuff in front comes along for the ride. And so the closest number to, basically we're saying this measurement was good to the 100th, this measurement was good to the 1,000th place, therefore the sum is only good to the 100th place. All right, I didn't do that on the calculator, but you guys know how to use a calculator. F, my favorite problem, hint, hint, hint. I'm going to talk about this one, 76.915 liters minus 2.915 liters. If you do that on a calculator, by the way, this is this. You can only add and subtract if the units are the same. Your calculator will say 74 liters. That is not the answer in chemistry. Why? Because when you add and subtract, you count decimal places. This has 3 decimal places. This has 3 decimal places. This answer needs to have 3 decimal places. So I need to do this. Now, people, this drives me crazy. It drives you crazy. I need to say this. All of these numbers are the same number. I get that. I have my master's in math. I get that. 74, 74.0, 74.00, and 74.000 liters are all the same number. But when you have an answer to a calculation in chemistry, you get two pieces of information. The first piece of information is what the number is. It's 74. The second piece of information is how good were your measuring instruments. And this says that our measuring instruments were accurate to the thousandth of liter. Because of that, this is how you indicate to a scientist that not only is the answer 74, but the measuring instruments were darn good as you put those extra zeros in there. This is how you write 74 if it was good only to the nearest 1 liter. This is how you write 74 if the measuring instrument was good to the nearest tenth of a liter. This is how you write 74 if it's good to the nearest hundredth of a liter. And this is how you write 74 if it's good to the nearest thousandth of a liter, or 3 decimal places. That is a very important problem. It's going to drive you nuts for a while. All right. G is 3.35 meters plus 2.0 meters. You can only add numbers if the units are the same, and they are. And if you do that on your calculator, you will get 5.35 meters. That's not the answer in chemistry. Why? Because when you add or subtract, you count decimal places. That means we only care about digits after the decimal point. That has 2. This one has 1. It's always the least. We only get 1 place after the decimal. 5s round up, so this is 0.4, and the stuff in front of the decimal point comes along for the ride. So the best answer in chemistry is 5.4. Why? This indicates to a scientist that your least accurate data point was good to 2 decimal places, and that's not true. Our least accurate data point was only good to 1 decimal place, and so that's the way we have to write it. H is, and this is, you might have to practice getting this in your calculator, but 6.7 times 10 to the 4th second squared over 3.25 times 10 to the 4th seconds. We're dividing. I want to talk about this first. If x squared over x, this cancels with one of these, is x, does that make sense that seconds squared over seconds would simplify to seconds? And so let me grab an eraser just because I'm not sure that I have that in the right place. That second, okay. Now I'm going to go back to the calculator, because when you're putting this in your calculator, be very careful that you use parentheses, especially when you're dividing. So 6.7 times 10 to the 4th, close, divided by parentheses 3.25 times 10 to the 4th, boom, boom, hit equals. It tells you that the answer is 2.06153,846 K. Being obnoxious, being very obnoxious. This is what my calculator said, 2.06 153,846 seconds. Now, because we're dividing, we don't count decimal places, we count Sig Figs. This number has 2. This number has 3. We always get the least amount. I get 2. This is a 6. It rounds up. Best answer to this, the only answer to this in chemistry is 2.1 seconds, because you can only have 2 Sig Figs. All right, moving right along. We're getting there. We're almost done. This is I. We have 427 meters divided by 0.65 seconds. I'm going to, when I do my calculator, I get 656.9230769. I got a meter on the top, a second on the bottom. Nothing cancels. I got a meter on the top, the seconds on the bottom. We are dividing. We count sig figs. This guy has 3. This guy has 2. We only get 2. I'm in a box in the first 2. What's touching the box is a 6, so this is 6, 6, because the 5 rounds up. But if this is a 3-digit number, you have to fill in this last place with a 0. So if you write it like this is like a NASA laser balance. This has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. If you leave the answer like this, you say that your least accurate measurement was good to 10 sig figs. That would be about $19 million. Your least accurate number was only good to 2 sig figs, and so this answer has to be rounded to only 2 sig figs. All right, and last one. This is a very hard one to get in the calculator, but you can do it. J is 2.00 times 10 to the 7th meter times 3.65 times 10 to the negative 4 meter. And then this is 3.6 times 10 to the 2nd meter. Sorry. And a meter times a meter times a meter is a cubic meter, and that's a unit of volume. So I'm going to write that here. I'm doing my last one. Hit clear. Again, you have to use parentheses. So we have 2.00 times 10 to the 7th, I believe. Close, close, times. I think this understands implied multiplication. By the way, let's just get this right there. And then I get 6.35. Sorry, need to back up. 6.35 times 10 to the negative 4. Close, close, and then we have 3.6 times 10 to the 2nd. Close, close, enter, enter. All right, doesn't like something here. I think I got to go in and put the times, and I got to go back and put the times. Let's see if I get an answer now. Yes! This is the same answer I got on my key. That's a good thing. This is 4,572,000. Now we're multiplying. This has 3. Remember when a number's in scientific notation, you only look at this? This has 3. This has 2. We only get 2. What's touching the box is good. This 4, this is a 6, and this 1, 2, 3, 4, 5 places have to be filled in with zeros. Otherwise, you're going to think that 4,472,000 rounds to 46. No, the closest number to 4,572,000 with 2 sig figs is 4,600,000. And that's the answer in chemistry. And so let's just go back and summarize, and then I will shut this off. I come way down here, sorry. So what do you do when you do a problem? You do the math like a middle schooler. Use the calculator, write down the answer, then decide, are you adding and subtracting? Because if you're adding and subtracting, you have to round your 7th grade answer to the smallest number of decimal points. If you're multiplying or dividing, you have to round your 7th grade answer to the least number of sig figs. All right, watch this. My lecture was 29 minutes and 29 seconds.